W. Curtis Preston from TrueBit TV, sitting here with Robert Novak, the Director of System Architecture for Nexenta. How's it going, Robert?
It's going terrifically well. We're having a great day today.
It's a big day for you guys. You guys had Hillary Clinton here speaking that just finished. That was very exciting. It's a lot calmer in here now that the Secret Service is all gone. You and I had a conversation earlier where I learned quite a bit, and I just wanted to share that with the audience. You mentioned how that the whole industry is based on technology. You said what, 130 years old?
125 years old.
Yeah. And what technology is that?
Well, it's block devices. The logical block address is based on the technology that was used in the 1890 census here in the U.S. called the Hollerith card.
Mm-hmm.
That was a punched card to tabulate the data. And the block records that we store on storage devices today are an outgrowth of a composite chunk of those block or unit record devices. And just now we're beginning to see the emergence driven by database developments to shift from blocks and keeping track of block numbers that are physical hard addresses.
Right. I take a block and I literally put it in a place.
And you know the index or address of that place.
Right.
So every major advance in computer science has had to do with delaying the binding of information to locations. In early machines, we had absolute addressing, jump to location 512.
Mm-hmm.
All right, then we jumped to label X.
Mm-hmm.
Then we had dynamic linking that would put X but come and load it later, so we jump indirectly. So the new form of delayed binding that's going to impact the storage industry is key value, so that a block address is never known outside the scope of the device itself. So that if you want data, it's what I call the Chinese laundry ticket model.
Okay.
You have to give it the ticket to get the laundry.
No ticket, no laundry.
I wasn't going to say that, but so that it becomes a very simple model. You hand over the data, and you actually tell it what ticket, but you use that ticket, and you want the data back, you give it the ticket. In a modern networking environment, rather than the closed storage servers we've had today, where storage devices are accessed over Ethernet, it means now you don't care where the data is. You just say, who has this ticket on the network?
That's I remember when it was Seagate that announced the IP directly IP addressable drives, right?
Yes.
And I remember when they announced that, and I remember going, well, that's interesting, but I honestly didn't know what would happen next. And so this is what's next.
This is what the outgrowth is.
You can literally, and by you I mean a company like yourself, certainly not me, can literally just put data out there, and then you can request the data by its identity rather than its location.
Right.
And what I understand that would allow is that you can put that same data in multiple locations, right? And then when you request it back, if one of those locations is offline for various reasons, it really doesn't matter. You get the data from whoever happens to be alive and responding.
It goes even further than that. With the Nexenta Edge product that we just announced this week, you can take it a step further because you can get dynamic load balancing. Because when you say, who has it, they can come back and say, I have it, and I can name that tune in 18 microseconds. And so then you can pick the fastest.
With that reference, by the way. Whoops, here we go.
Sorry about that. So
you're definitely dating yourselves.
But that's the concept, that you can pick the fastest one that's available at this moment, so that you're always taking the data from the server that can provide it fastest, rather than inconsistent hashing models where you have to go to a fixed location. You pick the fastest one available. So this dynamic load balancing has all the other implications, because the data not being location dependent, if one of my storage devices is filling up to above 80% capacity, I can take some of that data and shuffle it off to other devices that are not so full, and that way I can rebalance all the storage.
That's not very friendly to things like RAID.
Who
the
needs
look
RAID?
On, the look on your face.
It's like,
Who needs RAID?
Who needs RAID?
There's a great video on our website called I think it's like Bleep RAID. I think is what we called it, and it just talked about all the reasons why RAID is dead. This is one of the reasons.
This ties back to our conversation earlier that when you have RAID devices, you can have silent errors, just like you can have on a disk drive. You can have a silent error. In a RAID environment, you're doing two-step transactions. You have to read out the data, modify it, write it back, read out the other members, recompute the checksum, and write that back. 2 steps.
Right.
If you have a failure in the middle, you've just lost everything.
Right.
In this type of model, you're only writing once, a copy on write type
Right.
of environment.
Right.
Write it once, forget about it. Use strong cryptographic hash protection like SHA-256 to verify. Trust but verify
Right.
every piece of data that comes back from hardware, because I never trust hardware.
Yeah, well, of course you don't. You're a software company.
Yes.
All right, well, listen, thanks for taking the time to explain that.
My pleasure.
And thank you for watching. Make sure to check out our other videos on TrueBit.tv.